So in 11.2 we finally get to the vertex form. So vertex form. And the vertex form is the combination of the h direction, left to right, and the k direction of up and down. So it looks somewhat like this: a parentheses x, and I say plus and minus h because it could be either plus or minus, and it's squared, and then plus or minus k. And so now we have the final vertex formula going on here. And this is useful because now we know A tells us if it's positive A, then it means that the parabola is going to go up. If it's a negative A, then the parabola is going to go down. If we know that A is going to be greater than 0, then we have a vertical stretch. Vertical stretch. That just means that we have a parabola. It's instead of it going its normal way, the stretch would mean it would climb quicker. Okay? And so if A is greater than 1, or actually we should say it's 1, not 0. So let's get that, take that out. It's really 1. That's what I meant to say. Okay, and then if A is between 0 and 1, then we have what's called a fraction, right? So some type of fraction for A, and that causes the parabola to actually become more wide, if you want to say, because here is the normal equation, let's say, of y equal to x squared. But when we have a fraction, it tends to bow out more. Okay, it's pulling more in the horizontal direction than the vertical. And so A does a lot of different things. So we have to really pay attention to what A is. The plus or minus h. The plus h, of course, just means that it's going to move to the left h units, right? And if it's negative h, it's going to move it to the right h units. The plus or minus k, well, the plus k moves the parabola up k units, and the minus k moves it down k units. So now we know what everything does in the particular equation. So if we look at an example, let's say we wanted to look at an example of this. Let's say it's y equal to, let's keep a at 1, so that's x plus 2 squared minus 4. The h is going to be plus 2, so that means it's going to move to the right 2 units. And then the k, since it's minus 4, it's going to go down 4 units. And so we can see that right away. So if we go to our graph and we graph that, we go to y equals, let's keep the original x squared, and let's clear out these other ones. Okay, and we'll go to the y2 and we'll type this in. So parentheses of x plus 2 closed to the power of 2, and then that's minus 4, and then hit zoom 6, and you can see here's the original, and then here is the moved parabola, meaning it's going to move it 2 units to the left and 4 units down. So this lower point, the minimum point here, the vertex point, that's what that's called, is going to be there. So if I was to graph that, it's an easy thing to do because the equation gives it to us. So here's my graph, and so my normal equation always is at the origin, right? And it does this. That's the y equal to x squared. But this one looks like it goes to the right 2 and it goes down 4. So I can go to the right 2 and down 4. And so here's where my new vertex is. And so the lowest point is called the vertex point. And it also could be the opposite. It could be the highest point. And so here's the vertex. It's actually moved 2 and down 4. So now it looks like this now. So the lowest point, or it could be the highest point in the parabola, is called the vertex point. Okay, because it's the most usual one. So this is just an example of how we know. If we did a different equation, like let's go ahead and do f of x equal to 1/2 times x minus 5 squared and then minus or plus 2. Now we know that the a is 1/2. That means we're going to have a much wider parabola because it's a half, and since it's plus, we know that it's going upward. So upward, I guess that's not really a word, so let's go back. So it's upward, and then the h is -5, so it's actually going to the left, or it's going to the right 5 units, and the k is plus 2, so it's going up 2 units. So if I did the graph, okay, I could say, okay, I go to 5, so 1, 2, 3, 4, 5. That's the direction of the h. Okay, and then I go up 2, so 1, 2. Here's where my vertex point would be, and it's not going to climb as much, so it's less steep than the original parabola. If I really wanted the exact, I'd have to plot some points to actually do that. So, but this is a rough idea, and plus I know it goes upward because the a is plus in the actual quadratic equation. And so this is what's called a vertex form equation.